जो भी CCNP में पढ़ा है वो आइडिया है.
Okay, so can you just tell me about the switch? A switch. What is a switch? Like how you can explain a switch?
It is a device which actually a device which will spread the क्या बोलते हैं ये जो the device which can do the broadcast in one domain, that is a switch basically.
Okay, so what is broadcast and why we need broadcast?
Hub is something which will copy and paste all the frames through all the ports, but a
Okay.
switch is something which will learn dynamically and it will broadcast through
Accordingly, okay.
accordingly. Yes.
Okay. And any other idea about switch? Like
It can learn the
function?
MAC addresses,
Okay.
and it can provide security
Okay.
based on ports.
Perfect.
There are a lot of other functionalities like Ether channel and all that. So,
Yeah. So basically, like we will start. Like let me show you. So like this, we will start. Okay. So first of all, like we will discuss about the switch operation. Okay, the basic switching. So today we will start the basic switching. Okay. Whenever a switch will receive a packet, so what will happen with the packet? Okay, what will be the first task of a switch, and what is the last task of a switch? What table it will maintain? What are the functions of a switch? Everything. Okay. What are the layer 2 forwarding, layer 3 not layer 3 forwarding, on layer 2 forwarding. Port will mapping, the switch port description, duplex. So these things we'll discuss today. Okay. The next day, and we'll start with CDP LLDP. So I think you have a like sound knowledge of CDP LLDP, right?
Bharata, I do remember CDP and LDP, Cisco Discovery Protocol and Link Layer Discovery Protocol.
So Akib, any idea about CDP LLDP? Any idea?
No, sir.
Okay, no problem. So Funke, any idea about CDP LLDP?
No idea.
Okay. So first of all, today, like we'll just go through with the topics. Okay. So what is CDP, what is LLDP? Basically, let's suppose we have two devices. Okay. Now what I want to get the characteristics or properties of the device of my neighbor. Okay. So what I can do, I can use a protocol that is CDP or LLDP. Okay. Let's suppose we have two switches or two routers. Okay. So this protocol we can run on switches, on routers both. Okay. And whenever I will connect two devices, so they both will exchange the information about each other, like what is the port ID, what is the username, what is the IP address, what is the platform. So these types of like properties the devices will exchange. Okay, so let's say in CDP LLDP, so this is a discovery protocol. Okay, so it means, let's suppose we have two devices. I'll connect two devices here. This is R1, this is R2. Okay. Well, let's say, let me take here two switches, L3 switches, then we'll see what will happen here. Okay, this is your L3 switch, this is your L3 switch. I think all of you have the basic knowledge of L2 switching, L2 switch and L3 switch, right? Akib, Chaitanya, what is L2 switch, what is L3 switch, that is clear?
Clear है.
A basic idea.
I mean, क्या बोले?
A basic idea only basic idea. Like
basic idea L2 and L3 पक्का पता है.
Perfect. So here we have switch number 1, okay, and this is your switch number 2. So let's suppose we are using here a L3 switch. So this is your L3 switch, okay, and same here, this is your L3 switch. So basically here, what will happen here, let's suppose the username is here, that is switch 1, okay, the IP address is using 10.0.0.1, okay, the platform, this device can support a layer 3 routing, right, layer 2 properties, and let's suppose it also support multicasting. Okay, so what will happen here, this device will exchange the information using these protocols to this neighbor and to this neighbor. Okay, it means these two devices will be having a knowledge of neighbor. Okay, what is the IP address, what is the interface number, what is the username, what is a platform, that is a Cisco router or a open stand router, anything. So this is a protocol that will let us know the information of my neighbor. Okay, so, okay, this is clear to you. What is CDP and LLDP? A basic idea only.
Yes.
Okay, perfect. So whenever, if someone asks like, do we have any protocol to get the information of the neighbor? So yes, we can say that is CDP, or we can use LLDP. So in what case we use CDP, in what case we use LLDP, we will discuss. Okay. Now the next protocol, that is VLAN. So Funky, any idea about VLAN?
Virtual LANs, you know?
Yeah, it's Chaitanya, tell me.
Visual local area network,
Virtual
right?
local area network. Okay, so what is the benefit of VLAN?
That I have no idea.
It can segregate different LANs.
Right. So let me, first of all, let me explain like what is the benefit of VLAN. Okay, I will not go into the deep. Okay, but yes, I will explain the overview. Okay, so let's say here we have a switch. Okay, and that's it. And I'll connect, let's suppose 1, 2, 3, 4, 1, 2, 3, 4. Okay. So right now, let's suppose by default, as I told you, like here, all of the switch ports will be the part of single VLAN. So by default, we have a single VLAN, that is VLAN 1. Okay. So these ports will be the part of VLAN 1. Okay, Funky? This is clear to you?
Yes, you said like we have different network, the way you do the diagram.
No. I'm
Then
not talking
you
about
say one
network.
part have
A
one
single
area
network.
network.
I'm just talking about the single network. This is your switch, and we have 1, 2, 3, 8 PCs are connected via this device. That's it. Okay.
Okay.
All are having the same range, 10.1, 10.2, 10.3, like this they have. Okay. Now, what I need here, let's suppose if this PC will send a packet, a broadcast packet, so all of the devices will receive the packet, right? Let's say these 4 PCs are the part of sales department, okay, and these 4 PCs are the part of, let's suppose, admin department, okay. So now what I want, whenever this PC will send any broadcast, so only these 4 PCs should receive the packet. Same here, whenever any of the PC from the admin department send a packet out, only these PCs should receive the packet. So in that case, what I can do, I can break this broadcast domain using this VLAN, okay. That is just like a packet. Let's suppose I have a carry bag. Okay. In this carry bag, what I have, let's suppose I have some tomatoes, I have some potatoes. Okay. Now what I want to segregate these things. So what I will be using, I'll be using 2 packets, right? One for the tomatoes, one for the potatoes. So that is just like a VLAN. If I want to segregate these things, so I can use a VLAN feature. Okay, Funky? This is clear.
Okay.
I just want to send a broadcast to another domain. Let's suppose we have 2 domains, same thing, sales and admin. I don't want to send a broadcast from sales to admin, from admin to sales. Okay. So what I can do, I can use a VLAN feature just to break the broadcast domain. Okay. Clear?
Okay, you use VLAN feature to break broadcast domain. Okay.
Yeah. So this is just an overview. Okay. Now the next thing here we have, that is DTP. So Chaitanya, any idea about DTP?
Dynamic trunking protocol.
Okay, dynamic trunking protocol. So can you explain me like what is DTP?
DTP is used on both the switches, on both the ports, so that different VLANs can use the same port to travel between the switches. So it's like a single highway used between the switches.
Okay. So basically, let me explain you like a basic thing. Let's say we have a switch. Okay. If someone asks like what is DTP, so basically we use this protocol for the dynamic negotiation. And for what dynamic negotiation? Let's suppose first of all on a switch we can have 2 types of port. Okay. The port can be access, either it can be trunk. Okay. Okay. So on a switch we can have a access port or a trunk port. That's it. Only these 2 ports we can have now. What we are doing here, we're using a protocol that is DTP, dynamic negotiation. So this switch will like automatically negotiate this thing if this switch is having a connection with PC. Okay. A port connected to PC, that will automatically be access. Okay. And if this port is connected to a switch a port with switch. Okay. So port will be trunk port. So just for these 2 negotiation, for the access port, for the trunk port, what we use a protocol that is DTP. Okay. It means automatically, if I will connect a PC or end device, that port will act as access port. If I will connect a switch, that port will act as a trunk port. Okay, Funky?
ट्रंकिंग राउटर के साथ भी होती है ना?
ट्रंकिंग राउटर के साथ होती है, yes, but एक अलग सिनेरियो बनता है वहां पे, बात करेंगे जब आगे आएंगे. So, Funke, Chaitanya, any doubt till this point?
No, it's fine.
Okay, perfect. So I think the overview of DTP is clear, right? Funke?
Yeah.
Okay, perfect. Chaitanya, like any doubt in this one?
No, sir, clear, sir.
Okay. So then we'll start VTP. This is called your VLAN trunking protocol. Okay, so before this, like we have to make sure all the devices should run DTP. Okay, if they will be having a trunk port, then like we can run this protocol VTP. So Chaitanya, just give me any idea about this VTP.
So VTP acts like a server. It has 3 modes in it: server, transparent, and a client mode.
No, just
so
give me
instead of
an idea. If someone asks, like you have to explain VTP in single line, so what you can say?
it's a protocol used to what do you call spread the same VLAN information between n number of switches.
Perfect, perfect. Let's suppose in my domain we have 100 switches. Okay, so my boss asked me to configure, like you have to configure VLAN 10 everywhere. Okay, so the first day I'll go to all the devices and I'll configure one by one. That is fine. Okay, the next day again the boss asked me to configure VLAN 20. Okay, then again next day the boss asked me to configure like the another VLAN. So in that case, I have to go daily. I have to go to the 100 switches and have to connect the console and have to disconnect, disconnect, and have to configure, right? But in that case, like it will take a lot of time, right? So what I can do is I can use a protocol that is VTP. Okay, so this is a one-time configuration. So only for the one time, only for first time, we have to configure VTP on all the switches. Now in future, once my boss asks me to configure, let's suppose VLAN 10. So what I will do, I will just configure that VLAN 10 on one single switch, and that switch using VTP will propagate the information throughout the domain. Okay, if again let's suppose my boss asks me to configure VLAN 100, so again I will just configure VLAN 100 on a single switch. That switch will propagate the information throughout the domain. Okay, so Funky, this is clear to you? What is the benefit of VTP?
Yeah.
Okay, so it is a feature to propagate the VLAN information throughout the domain. Okay, it means no need to do one by one, just do on single device, it will propagate everything. Okay, then after that we have spanning tree STP. So basically this is a protocol to get a loop free topology in a L2 network. Okay, so right now we have this protocol spanning tree to get a loop free topology into a L2 network. But if I talk about a packet, whenever I will, let's suppose I will do a ping packet. Okay, I will do a ping. So it will add ICMP packet, right? Then it will add layer 3 header. So in that header, let's suppose we have some addresses 10.0.0.1, 20.0.0.1. Okay, in this one also it will carry a TTL value, that is, let's suppose 24. Okay, so by default it will be 255. Okay, then in L2 it will carry let's suppose the MAC address is A, the destination MAC address is, let's suppose, that is all F. Okay, and not all F, let's say, yeah, let's put all F. Okay, no problem. And enter, and then it will put on the segment, right? So once a switch will receive the packet, let's suppose we have 3 switches. So like this, we have switches connected to each other. Okay, so this switch is to receive the packet, it will check the broadcast. So it will do broadcast. So this will receive, this will receive, this will receive, right? So it will keep circulating. But once this value will be 0, the packet will be dropped. So why we have this protocol spanning tree? Basically, the TTL value is like it will be decrement on each hop, right? So if they will decrement the TTL value, so what is the benefit of spanning tree? So can you give me any answer, Funke, Chaitanya? Okay.
At a layer 3, we have TTL value to stop the loops, but at a layer 2, we don't have anything. So spanning tree is used for that purpose, to stop the loops.
Okay, so I think you're correct, but just give me correct answer. If these devices are sending the packets to each other. Okay. So at that, so they will decrement this TTL value or not? I'm just asking. This is your switch 1, this is your switch 2, this is your switch 3. So they will decrement the value or not?
Yes, it will decrement the value.
So if they will decrement the value, so why we have this protocol? It means I know it if the packet will be circulate. So after like if I divide by 3, so after that answer it will like dropped automatically, right?
But we are talking about, I mean, generally, sorry, the TTL value generally gets decreased in routers, but we are talking about switches, not routers.
Perfect. Awesome. So these are the switches. So whenever a switch will send a packet out, it is just checking this information, right? That switch is not able to check the layer 3 information. So at that time, the switch will never check this information and will not be able to decrement any value. Perfect, Chaitanya. So in this condition, if switches are not able to check this value, so they will not be able to decrement this value and they will just do the forwarding on the behalf of this layer 2 forwarding, and the packet will be endlessly circulate in the network. That's why we need this protocol to break this loop. Perfect. So this protocol is clear, Funke. Why we are spanning tree?
Yeah.
Okay, so basically what we will be having here, like once we run here spanning tree, I will be having one link in the down state. So I will be having a topology like this. Okay. I will not be having any loop here. Okay. It is clear now.
Yes.
Okay. The next protocol we have, that is Ether channel. So in Ether channel, basically we have some issues in the spanning tree. Okay, so we use Ether channel just to prevent those things. Okay, so what we can do here, we can just bundle multiple physical links into a virtual link. Okay, so this is the use of Ether channel. It means we can now using Ether channel, we can have multiple ports between switches. At that time, the spanning tree will not put the ports in the block state. Okay. Then we will discuss interval routing, or we can say L3 forwarding.
Sir, a question, sir.
Tell me.
When I was reading CCNA, this concept of Ether channel came up. Obviously, it is bundling of different cables.
Yeah.
But if you draw a triangle, just like you have 3 switches in up in there,
Yeah.
and if you connect two links to each switch, obviously you can bundle 2 of them.
Yes.
Right?
Correct.
So if you bundle all of them, but if all of them are interconnected, it still is not going to prevent the looping, isn't it?
No.
Because obviously,
look here. At this time, what will happen? We are talking about this topology, right?
Yes.
Okay. So in this case, yes. At this, let's suppose we are not using Ether channel. So what will happen here? This link will be up. This link will be up, and the remaining links will be in the blocking state. Okay. But
Yes.
Start using the Ether channel. These 2 links will be up. These 2 links will be up. But now these 2 links will be in the downstream. Okay. Like
okay.
Prevent the loop.
Okay.
Because
okay.
at last,
clear.
once I will configure Ether channel, I will be having a link between this one. I will be having a link between this one, and I will be having a link between this one, right? So the switches will block one single link. Okay. It means indirectly the switches are blocking 2 ports. Okay.
Okay. So the complete Ether channel bundle between any one of the switches will be down fully.
Yes, correct.
Okay. Clear.
Then we have a protocol that is FHRP. So that is just like any idea about this one, FHRP, Chaitanya?
First hop redundancy protocol.
Yeah, like
if one router is down, obviously the other router will take its place.
Perfect.
And
So
it will share the same IP.
Network. Okay. So if one router goes down, let's suppose we have 2 ISP. Okay. In my company, we have 2 connection with 2 ISPs. So at that time, if first ISP goes down, so automatically the traffic will shift to the second network, to the second ISP. So just to achieve that task, we use FHRP protocol. Okay. Then we have syslog. We'll discuss about this one. NTP, span, like these are small protocols. Then switch security. Yes, we'll discuss about the security. So we have various ways to do a security in a switch. Okay, multiple ways. then triple P. So basically, this is a point-to-point protocol. Okay, we use in between customer and ISP. So whenever we get a connection from the ISP, so always that will try to give me a point-to-point connection always. So that thing we'll discuss in the triple P. And finally, the part of CCI, that is multicasting. So multicasting, like we will learn how the routers and how the local LAN will propagate the multicast packets to each other. Okay, like we have some protocols also in the multicasting. Like if I'll talk about unicast routing protocols, we have EIGRP, OSPF. Same in the multicasting, we have some protocols. So we'll discuss in the multicast. Okay, so this is overview. Let's start with the switch operations. Okay. So Funke, any doubt till this point?
No doubt.
Okay. So let's start today. So basically, a switch has three functions. The first function it has, that is MAC address learning. Okay. The second function it has, that is forward filter decision, and the third function it has, that is loop permission. So about the loop permission, we will discuss in the spanning tree, but right now we can discuss the MAC address learning process and the forward filter decision process. Okay. So basically, whenever like if someone talk about the switch, so we have to know these things. Okay, what is the meaning of MAC address learning? What is the meaning of forward filter decision? Okay. So whenever a switch receive a packet, the very first task, if I'll talk about router, okay, so whenever a router receive a packet, it will always check if the things are default, the device will always check the destination. But in the case of switch, whenever a switch will receive a packet, the first task, it will learn the source MAC address, okay? Because look, on the routers, we can use different protocols to get the information about the neighbor, right? But on the switches, like we don't have those protocols, we have to learn the MAC addresses like itself, right? So a switch will learn the MAC address itself. So the first task it will do, it will learn the source MAC and then it will do the forwarding. Okay. So the very first task is here. Switch will learn the source MAC address. Okay. So first of all, it will learn the source MAC address, and then what it will do will create a MAC address table entry. Okay. So once a switch receive a packet, it will learn source of the update. Okay, so the source MAC address it will learn and will maintain that entry in the MAC address table. Okay, so this is the first function of a switch. Okay, any doubt till this point? So whenever a switch will receive a packet, it will learn the source MAC and will create that.
No doubt. It's fine.
Okay, perfect. Now the second thing here, once it will do these tasks, okay, what it will do, the second task, we'll try to check destination, but before checking the destination, what it will do a forward filter decision. Let's suppose I'm getting a packet. Let me note down here. Let me draw diagram. So we have this switch. Okay. PC number 1, PC number 2, PC number 3, 4, and 5. The entries are like this. On port number 1, PC number A is connected for VLAN 1. On port number 2, PCB is connected for the VLAN 1. On port number 3, PCC is connected for the VLAN 1. On the port number 4, D is connected for the VLAN 2. And the port number 5, who is connected, E is connected for the VLAN 2. Okay, and let's suppose I'm getting a packet from this port on the port number 1. Okay, so the first task, let's suppose I'm getting the packet from same MAC address again. So what it will do, it will refresh this entry. Now the term I'm using here, that is refresh, right? Whenever a switch get a packet, it will create or refresh a entry. So this thing is clear. Okay, that will create the entry. But what is the meaning of refresh? Basically, the MAC address table timer is 300 second. Okay, it means, let's suppose we have this table 1 2 3 4 5. Okay, the port the MAC address A B C and D and E. So if this switch will not receive the packet from A B C D and E till 300 seconds, so what it will do, it will flush all of these entries from this table. Okay, that's why I'm saying here, whenever a switch get a packet, it will create or refresh an entry. Okay, it means if the entry is there, it will refresh that entry and will again start the timer from 0 1 2 3 like this. Okay, let's suppose after 100 seconds again it's getting a packet, the same packet again. So what it will do, it will again run the timer from 0 to 300. Okay, so that's why I'm saying here, it will create or refresh an entry in the MAC address table, and the default timer is 300 seconds. It means if a switch will not receive any packet from A B C D and E till 300 seconds, it will flush the camp table, or we can say the MAC address table. Okay, Chaitanya, any doubt till this point?
Clear, sir.
Funky, any doubt? Akib, any doubt?
No, sir.
Okay.
It's okay.
Okay, perfect. So this is the first task. Now the second task, we were discussing the forward filter decision. So this will think that I'm getting a packet from port number 1. Okay, so let's suppose the packet I'm getting here, the packet is having MAC address A. The destination I don't know right now. Okay, so what will happen here? It will check. Okay, I'm getting a packet from A in the VLAN 1. Okay, and the port number is 1. So at that time, it will instantly do a filtering. It will check, okay, I'm getting a packet in the VLAN 1. So I have to just check the destination entry in the VLAN 1 packet. So this is called your filtering. Okay, so once it will receive the packet, it will do a filtering in the VLAN. Okay, so these three MAC addresses are the part of VLAN 1. These two addresses are part of VLAN 2. Now this device will not check the destination address in these two entries, never. It will just verify, it will look up, it will do lookup only in the VLAN 1. That is called your filter. Okay, now the forwarding. So once it will do a filtering here, okay, for the VLAN 1, and then it will keep checking, okay, do I know that MAC address? If yes, I will send the packet out to a specific port. If not, I will do a broadcast, or we can say flooding. Okay, so here, once a switch will do filtering of VLAN, so it will check destination, and if find the same MAC address for a specific port, so it will send the packet out. But if did not find any entry, so it will flood the packet to all active ports. Expect on which packet was received. Okay, so the device will do the broadcast, will not do the flooding on this port, because from here I was received the packet, it has received the packet. Okay, so the device will do the flooding to the remaining active ports. Okay, so Akib, Chaitanya, Funke, any doubt in these 4 lines?
Sir, one quick question, sir.
Yeah.
So if you have multiple VLANs in the switch, would it maintain all the information of the different VLANs and different computers in the same CAM table, or would it assign different CAM tables?
Same CAM table, same CAM table. That's why that will do the filtering. Otherwise, there is no concept of filtering, right? Let's suppose I'm trying to maintain a CAM table for different VLANs. So at that time, it cannot do any forwarding, right? Never. Sorry, it cannot do any filtering at that time, because I'm getting a packet in my MAC address table. I will just check the same MAC address table. So where we have the concept of filtering, right?
Okay.
Okay.
Clear.
So always it will maintain a single MAC address CAM table on a switch always. Okay.
Okay. Clear.
Funky, any doubt till this point?
It's fine.
Funke, if things are not clear, you can ask me. I can start from scratch, not problem. Okay.
Okay.
We all are zeros here, so you can ask anytime, no problem. Okay. Ask if you have any
Alright.
doubt. Okay.
Alright.
Okay. So the second task is forward filter decision. First of all, it will try to do a filtering for the VLAN, and then it will find the correct MAC address, and then it will do the forwarding. Now, so this is about the normal switch operation. Okay, or we can say this is the functions of a switch. Okay, always the switch will do these three functions. Now, so about the loop prevention, we'll discuss once we start the spanning tree. So I will draw a diagram. Okay, I will like draw topology, and we'll see the packet types and these things. Okay, like what will be the first packet, what will be the second packet, third packet, like this. I will check. So I will draw a diagram like this. I'll connect a switch here. I will connect a switch here. A PC here we have. Another PC here we have. Is connected to this one. Like this. So let's say this is your port number 1. This is your port number 1. This is your port number 2. And this is your port number 2. This is switch 1. And this is your switch 2. So at this time, first of all, okay, this is your layer 3 device. Okay, so as I told you here, the MAC address table timer is 300 seconds. So whenever a layer 2 device will maintain a table that is MAC address table, so the timer will be 300 seconds. But whenever a layer 3 device, if I'll talk about a router or if I'll talk about a PC, that will maintain ARP table. Okay, what is ARP table? Address resolution protocol table that will carry your IP address, your interface number, and your MAC address only. Okay, but if I talk about MAC address table, that will also contain your VLAN ID, but it will not contain your IP address. Okay, so if I talk about MAC address table, okay, that will just carry the MAC address, okay, your VLAN ID, okay, and your interface number on which packet, on which interface you have received the packet. Okay, but if I talk about ARP entry, okay, so it will maintain the IP address associated with MAC address and the interface also. Okay, so like this they will maintain. So this is your L3 entry and this is your L2 entry. Okay, so I think the difference is clear. So this entry, the switch will maintain for 300 seconds. Okay, but the ARP entry, the device will maintain for 4 hours. Okay, so the flush timer for the ARP entry is 4 hours. Okay, it is clear. Any doubt to this point?
Yes, sir.
Chaitanya, Funke, okay. Any doubt to this point?
Clear.
No,
Sir.
sir.
Okay. So on this diagram, we will start the work. Okay, we'll check the information. So let's suppose these are the brand new devices, switch 1, switch 2, and we have two PCs. This is your PC 1 and this is your PC 2. Okay, so what will happen here? The first task, what I will do, let's suppose I don't know what is a DSP server. So what it will do, it will try to get the IP address from the static way, right? So I will configure here static way. Or let's suppose I'm not a technical guy. Okay, I have just purchased 2 devices, 2 PC and 2 switches. So at that time, I'm not technical guy, so I cannot use a DSP server to get IP address, and I don't know how to configure static IP address, right? So if we don't have these 2 ways, so what will happen here? The devices will automatically get IP address from a feature that is APIPA. Okay. So if we don't know about DHCP or static IP address configuration, so only Microsoft device will try to run a automatic private IP address assignment mechanism. This is called your APIPA. Okay. So automatically the device will try to run this behavior, this mechanism APIPA. Okay. So using this information, automatically the devices will get IP address from the range of 169.254.0.0 to 169.254. So guys, any doubt to this point?
No, sir.
So this APIPA is clear.
Clear.
Yes, sir.
Funke, this is clear.
Yes.
Okay. So it means if we don't know how to configure static IP address and how to configure the DSP server, so yes, the device will automatically get IP address from the APIPA, but only this is true only for the Microsoft, okay, not for the vendor. Now let's suppose I better know how to configure static IP address, so I will try to configure static address here and static address here. So what will happen, you will see. So I will try here 10.0.0.1 and then I'll just configure the mask also. Like this. So once I will press enter here, what it will do in the background, it will run a task. Okay. So once a device gets a IP address from any other method, any method. Okay. So in the background, it will run a mechanism to check the duplicate IP address. Okay, because in the background, let's suppose I want to use 10.0.0.1. I have to verify someone is using or not. If that IP is free, then only I can use that address, right? So whenever we assign any IP address, so in the background, the device will automatically check this thing, someone is using this address or not. And how this will check? Using a packet, the packet name is GR. Okay. Gracious R. Okay. So in the background, the device will run a mechanism that is GR. So using GR packet, the device will just do a lookup in the domain. Do I have the same IP address in my domain or not? Only for the local LAN. So this mechanism works only in local LAN. Okay, not outside the LAN. We can just check the duplicacy in the local LAN only. Okay, always. So what is the mechanism, or like what is the packet content it will send? So once I will press enter here using this address, it will send a first packet. So the first packet will be from PC, that will be GR. And now how the packet will be look like? It will add some headers. Okay. First of all, it will add a GR packet, right? So in the GR packet, it will carry some other information, like it will carry sender IP address. So what is sender IP address? That is 10.0.0.1, right? 10.1 I'll put here. What is our sender MAC address? So let's say sender MAC address is A. Okay. Now what is the target MAC address? So right now the target IP, the target IP will be, it's my IP, right? I want to verify someone is having the same IP or not. Okay. So in this packet, the target IP will always be 10.0.0.1. Reason, I want to verify someone is having this address or not. Okay. But this time the target MAC will be all F, because I want to send this packet out to all of the devices to till the layer 2. Okay, they should check this information. Yes, I can listen this information, then only they will verify 10.1. Okay, so at this time the device will put these things in the GR packet. Okay, and then it will add layer 2 header here. So in the layer 2 header, the device will put source MAC, that is A, the destination MAC, that will be all F, because I have to do a broadcast in the local LAN to send the packet out to all of the devices. Look, what will happen here? Once the device will receive the packet, what we need here, the switch should do a broadcast, right? So if we need this task, so here it should be all F. So the device will create this packet and will send the packet out to switch 1. So now once switch 1 will receive the packet, it will learn this MAC address A. Okay. And once it will learn the MAC address, it will check the destination MAC address and will do the forwarding. So right now this switch will maintain on the port number 1 what I have MAC address A for the VLAN 1. And again switch 2 will receive the same packet. It will maintain the entry on port number 2 what I have MAC address A for the VLAN 1. And switch 2 PC2 will receive the packet. It will check, okay, no, I don't have this address, so I have to ignore the packet. And this packet will always be a reply. Okay, so nature of this packet is a reply packet. Whenever we talk about any other protocol, okay, always that packet will send a request, but this packet will always be a reply. It means only in this mechanism I can get a reply from a reply. Okay, so using this mechanism, using GR packet, the device will check the duplicacy. It means again, if let's suppose in future I'll configure here 10.0.0.2 255.0.0.0, it will check the duplicacy in the background. It will create a new packet again like this. It will add first of all source IP address 10.0.0.2, right? Sender IP address. The target IP it will put, that is same address. Okay. The source center MAC it will put, that is let's suppose B. The target MAC it will put, it will be OLF always, right? And then it will put the layer 2 header source MAC, let's suppose that is B, and the destination MAC will be OLF. That's it. So like this, the PC2 will create this packet, okay, and will send the packet out to the neighbor. So once the switch will receive the packet, it will again do the same task. It will receive on the packet number port number 1, will learn MAC address B for the VLAN 1. Same, it will receive the packet on port number 2 and will learn the MAC address B on VLAN 1. And this PC will drop the packet. If this one is having the same IP address, it will give reply. But right now, this device will drop this packet, right? So,
Hello,
Chaitanya, Akib, any doubt?
sir. Switch to सिर्फ L2 पैकेट देखेगा ना?
Yes, this is your L2 packet, correct. So switch just can check this address. Only this information it can check.
Sir, then why we need all that in L3?
No, this is not a L3 packet. This is your GR head information, okay?
Oh, okay.
This is your GR packet, the content of GR packet. Whenever a device will receive the packet, let's suppose this end device will receive the packet, okay? It will check, okay, I can receive the packet. It will remove the layer 2. Then it will come to the GR packet. It will check, okay, target MAC OLF, okay, I can receive no problem. But target IP is 10.1. It's not my IP address. So I'll just drop the packet, okay?
Okay.
Chaitanya, any doubt till this point?
Why is that clear?
Okay, Funky, any doubt till this point?
Clear.
Okay, perfect. So this is the very first packet where the devices will verify the duplicacy. Now the second packet, let's suppose here, basically the topology is fine here, right? Okay, the topology is stable. But if in future, let's suppose I want to do a communication, okay? So let's suppose I want to do a ping to address 10.0.0.2. So what will happen here? First of all, to create a packet, I should have all the layers information, right? So whenever this PC, the PC number 1 will create the entry, the packet, it will add ICMP. Okay, it will add IP header with source is 10.0.1, destination is 10.0.0.2. It will add L2 header, right? It will add the source MAC, yes, but right now I don't know the MAC address of the destination, right? So if I don't know a single information, the device cannot send the packet out. So once I will try to do this task, the device will try to do this task, okay, but it will check, okay, I don't have this information, so I cannot send this packet out. But to get to know about this information, what it will do, so if, look in this condition, the switches are having the information, but the PCs, the layer 3 device are not having the real MAC address information, right? So what will happen here, once a PC generate a packet, it will check all the information, and if MAC address is missing, so it will send ARP request to get the MAC address of PC. Okay, so at this time, right now, I don't know the MAC address of 10.02. I will try to send up ARP request packet to the neighbor. Okay, so the packet will be look like It will put this packet on hold, and what it will do, it will send a new packet with our request packet. Okay, this will be always broadcast. Okay, because I want to know the real MAC address of the device. Okay, so what the packet content it will put here, we will see. So this is your ARP request packet. Okay, and this is your L2 packet. Okay, that frame. So here it will put sender IP. So yes, it's my own IP address 10.1. Okay, target IP. I want to get that MAC of 10.2. Sender MAC, yes, it will put its own MAC address A. Now target MAC, I don't know. So what I will put here, target MAC, I'll put 0000 because right now I don't have any information about the destination MAC address. Okay, so that's why always in the ARP request it will put target MAC 0000. Okay, but now I have to send this packet as broadcast. So on the layer 2, source MAC will be A, the destination MAC will be all F. Okay, and again switch will receive the packet, it will maintain the entry, it will refresh the entry. Switch 2 will receive the packet, it will refresh the entry and will send the packet out to 2. So once switch 2 will receive the packet, it will check layer 2. Okay, I can receive the packet, it will remove the layer 2. It will go up and will check target MAC is unknown, but the target IP is my IP address. So I have to correct this information. So this is just like a fill in the blanks. So once PC2 will check this information, it will do a new task. So that will be like, it will give a reply with the correct MAC address, because this is not the real MAC address of the 10.2. So at that time, the device will send the information to the neighbor, and what it will send, so this is your ARP reply. That will be unicast. Okay. Sender IP, that is 10.0.0.2. Sender MAC is B, it will put the correct MAC address. Target IP is 10.0.1. Okay. Target MAC is A, correct. This packet will be unicast. So here it will put B and A. So once the devices will receive the information, this one will maintain the entry, will refresh the entry, same switch B, switch 2, one will refresh the entry, and finally one will receive the packet and will put the MAC address here. Okay. So it will remove this and put B here and will send the packet out to the neighbor. This will receive the packet and will send the packet out here. So right now, all of the devices are having an entry about the MAC addresses. So this is having information about 10.0.0.2. The MAC address is B. This is also having information about 10.0.0.1. The MAC address is A. Okay. Now, so this is the first task. If I'll do a ping, let's suppose in future I will do a ping. Okay, after 10 minutes. So what will happen here? First of all, the switches will flush the cam table, right? But right now the PCs are having the same information, right? They will flush after 4 hours, right? Now, what will happen here? If I will try to do a ping, yes, at this time the device can send the packet out with these information, right? With these information, okay? So once a switcher will receive a packet, so right now this switch is getting a packet, but first task, it will maintain this entry. Then second task, it will check the destination MAC. So it will find the destination MAC is unicast, but I don't have that entry in my table. So if switch get a packet and did not find destination MAC address in MAC address table, so it will flood the packet out to all active ports in same VLAN. Okay, so what it will do, it will flood the packet out to all of the ports, and this feature is called unknown unicast flooding. Okay, so this feature is called unknown unicast flooding. So in a switch network, if I will be having this diagram, a simple diagram, so what they will do, they will verify, they will do these tasks, like they will send GR packet, they will send the ARP request, ARP reply, or sometimes they can do the unknown unicast flooding. Okay. Chetan, any doubt? Akib, any doubt? Okay.
सर ये अननोन यूनिकास्ट फ्लडिंग कब होती है?
जब मेरे पास देखो, लेट्स सपोज एक स्विच के पास पैकेट आया, ओके, बट उसे नहीं पता डेस्टिनेशन के बारे में. देखो स्विच के पास तो क्या पैकेट आया, यूनिकास्ट पैकेट आया उसके पास, बट दैट स्विच डोंट नो हाउ वेयर इज दैट यूनिकास्ट, राइट? करेक्ट. लेट्स सपोज आई एम गेटिंग अ पैकेट
Yes. Okay.
B, but I don't have that entry in my table, so what I will do, I will flood that packet out. Okay, कि अगर मेरे पास एंट्री नहीं है तो मैं उसे फ्लड करूंगा डायरेक्टली. ओके.
सर बट वो GR नहीं सेंड करेगा पहले?
GR, only a layer 3 device can send a GR or RF request. Okay, a layer 2 device cannot send this information. Never.
Okay. Okay, sir. Okay.
It will just do flooding because it will it is an information. If I will get reply, so yes, I will maintain the entry. That's why it will just flood the packet out to all of them. Okay, because if that PC is the reply, and I will maintain the entry.
Okay.
Chaitanya, any doubt? Funke, any doubt?
Clear, sir.
सर आपका थोड़ा ड्रॉप हो रहा था.
चैतन्य, आवाज ड्रॉप नहीं मेरी.
सर क्या
आवाज ड्रॉप हो रही मेरी.
बीच बीच में कट हो रहा है सर.
ओके, कहीं मिस हो तो बताना मुझे. ओके.
हाँ.
So on switch we have some other things, like if I talk about duplex, okay, if I talk about speed, okay. So basically, if we are talking about duplex, okay, if we have half duplex, okay, the speed will be 10 Mbps by default. Okay, if I'm talking about full duplex, okay, it means the speed is 100 MB per second. So we can have two types of duplex. Basically, one more we have, that is simplex. Okay, so in the simplex we never count any speed. Okay, the simplex is just a way to send the information in one way only. Okay, and that is fixed for the life forever. But half duplex, that is something like the same thing. So just one minute. Half duplex, so this is like one way communication, but at a time. Okay, it means the next time it can send the packet out or it can receive the packet from the neighbor. Okay, but full duplex, that is a two-way mechanism. Okay, so the full duplex is a two-way mechanism that can send the packet out, can receive the packet anytime. Okay, and the speed we measure by default, the half duplex will be having a speed of 10 MB per second, and the full duplex will be having by default 100 MB per second. Okay, so whenever I see any port of 10 MB or port of 100 MB, that port by default will be having a duplex of half and full. Okay, so any doubt to this point?
No, sir.
Sir, yes, simplex and half duplex both are same, isn't it?
No. In the simplex, we can send the packet out. Let's suppose we are using a mechanism that is simplex, okay? And let's suppose at that time, I'm just talking to you. It means I'm sending the packet out to you. So that communication will always remain same. It means I will be able to send the packet out to you. You will never be able to send the packet to me. But if we are using a mechanism that is half duplex, so in that case, first of all, I will start the communication. So once I finish, then you will start the communication. Once you will finish, then I can start the communication like this.
Okay, take it, clear.
One-way communication at a time, but in the simplex, it will be a fixed communication that can be anyway. Okay, that can receive, can send. Okay. Funky, any doubt to this point?
No, not that.
Okay. So basically, we need to understand one more thing. What? whenever we work in a real scenario, okay, what we do, we will be having a physical topology, or we can say physical rack with some switches, routers, right? We have to convert the track into logical. Okay, it means, let's suppose here we have a switch, we have another switch here, okay, and we have three devices: router number 1, router number 2, router number 3. Okay, and they are connected to both switches like this. And one port we have in between switches. Okay, so this is the physical diagram, and this is your, let's suppose, R1, this is your R2, and this is your R3. Okay, this is your switch 1, this is your switch 2. Now what I want, my boss asked me to configure a topology like R1 should have a connection with R2, R2 should have a connection with R3, and R3 should have a connection with R1 again. Okay, so on the left hand side, that is my physical topology. I want to get this topology, the physical, into this logical. Okay, so I want to convert this topology of physical topology into logical like this. Okay, so if whenever let's say this is port number 1, port number 2, port number 1, port number 2, port number 1, port number 2, port number 1, this is switch port number 2, switch port number 3, switch port number 4, switch port number 1, port number 2, port number 3, port number 4. Now what I want, whenever the PC1 will send the packet out from port number 1, only R2 port number 1 should receive the packet. Whenever R2 will send the packet out to 2, R3 should receive on the port number 2. Whenever 3 will send the packet out using 1, R1 should receive the packet in port number 2, like this. Okay, so I need this communication. It means R1 should have a neighborship with R2, R2 should have neighborship with R3, R3 should have neighborship with R1. So I can use a mechanism of VLAN here. What we say here, port to VLAN mapping in physical diagram to convert the into logical. Okay, so if I know how to do this task, I can convert this physical into this logical. Okay, so what I will do, as I told you, a VLAN break a broadcast domain. It means whenever I will receive a packet in a single broadcast domain, I can just send the packet out to the same members of the VLAN, right? It means what I will do here, 1 and 2. So I will configure this port. Let's say I'll change the color. I will configure this port and I will configure these two ports. Okay, this port and this port. In VLAN, let's suppose 12. Okay, so I will configure this port in VLAN 12. I will configure this port in VLAN 12. Now, whenever R1 will send the packet out using port number 1, so only R2 will receive the packet. Reason, I'm getting a packet in the VLAN 12 and will just forward the packet out to VLAN 12. So the first task is done. Now let's assume it in between 2 and 3, I want to use VLAN 23. Okay, let's say here I want to use 23 in between 2 and 3. Now, this port, sorry, this port and these two ports, this one and this port, because R2 port number 2, R3 port number 2 are having connection like here. So I will configure these two ports in the VLAN 23. So whenever R2 will send the packet out here, only R3 will receive the packet, right? So this communication is done. Now in between 1 and 3. So the port 3 port is here and 1 port is here. So what I will do, I will configure this port in VLAN, let's suppose 13. I will configure this port in VLAN 13, and finally this trunk port I will be using to send the packet out to that port. It means whenever R3 will send the packet out here, this switch will forward the packet out to trunk port and this port can receive the packet. Okay, it means indirectly I will be having this topology after a port to VLAN mapping. Okay, so I think the port to VLAN mapping is clear.
Yes, sir.
Chaitanya, it's clear to you?
Yes, sir.
Okay, so we can convert any physical diagram into logical using a power to will mapping. Okay, so about the status of a switch, about the status of interfaces, we will discuss in the DTP. Okay, and about the okay. So basically for today, do you have any doubt? Till this point, we have done these things. Okay, do you have any doubt?
No, sir.
Chaitanya, any doubt?
No, sir. ये switches को कैसे simulate करना है GNS3 में?
On GNS3, I don't know, but what we can do, we will be using a new software that is WebIOU. So on that WebIOU, we can do all the practicals of switching. Okay.
Okay, ठीक है. But
Okay.
do we still need these images of switches?
I will share everything. Don't worry. Okay.
Okay, ठीक है. Right, no problem.
So from tomorrow, we will be starting these protocols. So today we have done the basics of switch. Okay, how a switch will create cam table, how a switch will create do the forwarding. So these things we have done. Okay, now from tomorrow we will start the protocols. Okay, so these are the protocols, and maybe it will take 1.5 months to complete this one. Okay.
Okay.
Sir, ये पूरा CCI का syllabus पूरा खत्म हो जाएगा ना?
Last correct. So maybe using multicasting or these things, so it will take around 2 months. Okay. But if I talk things, so it will take around 1.5 months. Okay.
Okay, ठीक है. And what is the time for tomorrow?
Same time, 2 to 4, 2 p.m. IST.
2 p.m. or 2:15?
2 p.m. If that
2
works,
p.m.
if you're comfortable.
2 p.m. बोले तो मुझे 6:30 यहाँ चलेगा.
Yeah, 6:30 for you. Yeah.
Okay, 6:30. Okay, ठीक है.
So any doubt to this point, guys?
No,
नहीं
sir.
sir.
Okay, so from tomorrow, we will start all the practicals, and the timing will be 2 to 4 IST. Okay.
Okay. Okay.
Okay, guys. Bye. Take care.